I was on mute. Why didn't you say something? Hello, everybody, and welcome again to the Scientific Origins channel. Today is going to be just a total treat. This should be nothing but fun and debunking and pretty pictures. So, when I was a young Earth creationist, when I was coming out of it, like figuring out that it was wrong, one of the things that really helped me was the internet, ironically. For a lot of people, the internet is how they get into a pseudoscience cult. The internet helped me get out of a pseudoscience cult. So, I put together this collection of some of what I think convincing visuals to support evolution. And I use these, I share them with evolution deniers in conversations. And this, I'm going to show you the image so you can screenshot it from this. I'll probably post most, if not all of them, up on my actual page later after the stream. And so you can just screenshot the video, or you can go to my page and copy it from there. But I'm also going to explain to you how to deploy these memes with maximum impact in your interactions with evolution deniers. I put this together for Objective Ethics, and he enjoyed it so much. I feel like I have to do it on my channel, unrestrained by a time limit, so I can just talk about all this stuff as much as I want. So here it is, visual data supporting evolution in deep time to help unmindfuck young earthers and evolution deniers. So one of the most well-supported lines of evidence are series of case studies in evolutions, populations of organisms that underwent especially extreme changes, like horses are a great example, because horses involve a small-toed, forest leaf-eating, toothed dweller, changing into a hooved, large plains-dwelling, grass-eating, toothed organism. So it's a really big change. And then another reason it's a really good evolutionary line is that even the creationists accept it now to a degree. And we'll go into that with these following memes. So here's the first meme I like to use. This is just a visual representation of the Equus line. You can also see, in the left, this middle, the very left column, you have the names of the species. Then this middle column, you have drawings of what the species themselves would look like. And you can get actual pictures of the species, the skeleton species. I have those. I think I put some of them in this presentation. And then on the very right column, you have, I think these are the teeth. It's a little hard to see, but yeah, I'm pretty sure those are the teeth or the hooves. Pretty sure the teeth. What you're seeing is hypsodonty, the development of a crowned tooth that's better at dealing with the silica that's in grass. If you were using a flat tooth, the tooth would be worn away by the time the individual is an adult, in which case it wouldn't be able to eat anymore, so it would die, and it wouldn't be able to pass its genes on. Evolution is going to select highly against that. And so this is another reason why this is a great line. Oh, is it not showing up? What's going on? There we go. Okay. Okay, so this is another reason why this is a great line of evidence to use. And I feel like everybody needs to know about this. Whoops, go back. Everybody needs to know about this, because this is a fascinating angle that you can work with evolution deniers. So do take this meme and use it. Because what this meme is saying is that the evolution deniers, the religious evolution deniers, the creationists, this is from Answers in Genesis. This comes from Kavanaugh. He's one of their stooges. This meme says that they created their own level, their own technique of analysis, right? Their own, they're trying to create something called baraminology. And what baraminology is it's a pseudoscience trying to imitate real scientific systematics, which is the science by which we categorize and classify living organisms. And they're trying to imitate that and make it fit the biblical kind. That's what baramin means. It means kind. So that's why they call it baraminology. And what this meme is expressing, this comes directly from Answers in Genesis, is that they use this baraminological analysis and they decided, using their own creationist-y methods, that these are a stratomorphic series, or they're a monobaramin, right? And what that means in layman terms is these guys are all related. So at the top of the chart, the modern equus, it's related to the ancient organism down at the bottom, the tiny toad forest dweller. So even creationists admit to macroevolution now. Isn't that fun? They just, of course, stayed real quiet about it. They put this out and then they never talked about the subject again. And so here's what some of the actual fossils look like. So this is a fun one that I like to use. Go ahead and you can screenshot this, or just go to Google and look up tapir skeleton, horse skeleton, rhino skeleton. And I like to post just one of these and ask horse or tapir. And a lot of the times I like to use the one on the bottom because it's not a horse or a tapir. It's actually a rhino. I won't tell them that there's a third option. So this is a great image for both debating with and unmindfucking evolution deniers, because anybody who looks at these things is going to go, wow, it's hard to tell which is which. By the way, the answer is the one on top is a tapir. I already told you the bottom one is a rhino. The one in the middle, that's equus. That's a modern horse. So that one's not even an ancestor species. Yeah, thank you, Big Bad Mama. Yeah, thumbs up to you too, of course. And happy Friday as well, Johnny. Hello, everybody else in the chat. So, continuing on. This one's a great image for unmindfucking evolution deniers because, once again, it comes from their own sources. Hey, Hizzle, good to see you. Comes from their own sources. Paleos, this is a theistic evolutionist guy, a creationist guy. I don't even remember. But he's more scientifically literate than the average dodo creationist. And he obviously has studied the horse fossils and horse anatomy a little bit. So what you're seeing here is the phalanges of the horse. So it might surprise you to learn horses still have toes. It's just the right two toes and the left two toes are pushed off to the side, and the third middle toe is huge, and it's got a really big, thick nail on it that we call the hoof. And so this is what we're actually seeing in this diagram. And once again, this comes from creationists. So another great image to use. Bring up horse evolution with evolution deniers and show them this image and remind them that their own sources accept horse evolution because they're pretty much backed into a wall on it. They kind of have to accept it. This is another one of my favorite images. This one is great because this is the first building block for a lot of bioscience skills. And there's a lot of social science to suggest that giving people knowledge doesn't cause science denial to dissipate as much as we might think it does, but giving people skills is very effective at dissipating science denial. So the skills you can gain from this one are just heuristic morphological analysis, comparative anatomy. And it's very obvious what we're seeing. This is what's called the one bones, two bones, many bones formation. This is extant in basically every pentadactyl, of which there are many. As you can see here, we've got a whale, a bird, a dolphin, a human, a horse, a bat, a cat, and all of these are pentadactyl. And so one bones, two bones, many bones, what that refers to is the one large arm bone, that's the blue one you see at the top, and that is the humerus, as you might know. And then the two bones, the next segment of bones is two slightly smaller, thinner bones than the thick bone at the top, and those are the radius and the ulna. And so that's the one bones, the two bones, and then the many bones is the final array of bones at the end there. And though in us those bones are our hands, but in other species they are, like in the horse, the hooves; in the bird, the wing; in the bat, the wing; and in the whale and dolphin, their flipper. So what you're seeing is a form we inherited from a common ancestor getting exapted to many uses, instead of organisms having something that seems designed for their niche from the get-go, right? This is a good argument against design, and it's also a good building block for biological skill. And a lot of times I see evolution deniers, their brain go into stun lock if you just hit them with one bones, two bones, many bones. Explain this formation to me. Explain the humerus, radius, ulna, carpals, metacarpals, proximal, intermediate, and distal phalanges. And most people who've never actually memorized parts of skeletal anatomy before, they're just gonna what? Explain what phalanges now? So what's next? Sauropods. Okay, we've gone over this in another video, but this is the meme, and I love this meme. I share this one a lot. This one's great for refuting evolution denial. It's great for refuting Pangea denial. It's great for refuting young Earth, all at the same time. This single meme refutes a ton of anti-science in just a single picture. So what we're seeing is different sauropod species, and we're seeing where they're distributed. And you see the orange and the red at the right of the chart. Those are species that are only distributed in South America and Africa. And then on the left higher part of the chart, you see that these ancestor species are distributed all over the world. So this is really good evidence that the areas where the ancestors are distributed were once in contact with one another. And it's really good evidence of macroevolution, the change in the sauropod group. And then at the very bottom, you've got some bonus artwork showing the Pangea and plate tectonics, how that has changed the shape of the land masses on the planet. Yep, just basic anatomy. Yeah, good old Anatomy 101. This is hopefully a refresher for a lot of people, but it's good to learn how to employ these images at top efficacy, because you can have the images, but if you don't know what they represent, just posting them, there's always going to be follow-up questions. So hopefully this helps you answer some of those. And of course, if you're inclined to use the dark arts, you can always go to an AI and ask it to explain things for you. And yeah, distal phalanges. Yeah. So the distal phalanges are the ones at the tip of the silly, stupid little sticks we have on the end of our arms. The proximal phalanges are the ones that are connected to the metacarpals. And then the intermediate phalanges are the ones it's in the middle, is connected between the distal and the proximal. And so that you can use that as a mnemonic device Remember, proximal means proximate to the actual hand, distal means all the way out there at the tip, and then intermediate means in between distal and proximal. So it can be easy to mix those up. So the mnemonic device is useful. So this is a great one. I think it gets brought up less because evolution deniers and young earthers and flat earthers, they hate defending their own ideas. They hate answering questions about their own ideas because obviously they can't, and their ideas don't really work. But this is a good one. So the Ark story, Noah's Ark, creates a lot of problems if you're actually going to try and make it work as a real account of history. And this is a great example of one. So it reads, when Noah's Ark finally rested atop Mount Ararat, kangaroos stepped off and hopped 7,726 miles straight to Australia. And without any opposable thumbs, they picked up every bone from their own dead so as to not leave a trace of their migration. So, yeah, what we're talking about is the fact that real life migrations happen. Organisms move around all the time. And when they do, they leave behind evidence of those migrations. This migration happened very miraculously, leaving zero evidence. I guess the kangaroos must be very good swimmers, and they must be good at sleeping in the water as well, which is an ability they've clearly lost in the modern population. Because, yeah, they landed wherever the Ark was, and then they made it all the way back to Australia. Same for all the South American penguins, same for koalas, same for countless other species that only appear in certain areas. It really does show how ridiculous and fairy tale like the Noah's flood narrative is. It's just completely impossible. It is quite remarkable. So I love this image. You can use either one. You can use the one that just shows the sea stack without actually circling an era. I like using the one that circles the era when you're talking to an outright young Earth creationist, someone who explicitly says they believe the Earth is young, because this red area represents about 6,000 years of accumulation from the top. So that gives you the 6,000 year timeline. But then there's all these other stacks. So obviously the 6,000 year timeline isn't long enough. And then about halfway down, you see that little white strip in the middle. That's limestone. And what's great about that limestone being in there is that limestone can't form during a catastrophic global flood. Limestone needs much calmer and much cooler waters than what would exist in a catastrophic cataclysmic global flood. So limestone wouldn't be able to form during that time. This little sea stack alone completely refutes young Earth creationism. It makes young Earth completely impossible. And it's all in one picture. And my favorite part about it is you can show this and you can talk about, the time it takes for the deposition to add up, the limestone, and then all of that leads you in directly into the heat and the mud problem. So we're going to make a video talking explicitly about those, so we won't go into them so much in this video, but those are fantastic one-punch knockouts for young Earth creationism. I'll go over them really quickly. So if you've ever been to both dry beach and a wet beach, or a dry cenote versus a wet cenote, you understand that things don't become dry that quickly. It takes time for a beach to become a dry beach, and you can see the difference between a dry beach and a wet beach. The reality is, if the entire Earth was flooded just 6,000 years ago, there wouldn't be a single dry beach on the planet. It just isn't enough time for that to happen. That's the mud problem in a short, truncated form. The heat problem is just the fact that basically every process on the planet, every natural process, produces some level of heat. It's usually a rate of heat displacement that's negligible and unharmful to the planet. But if you try and fit all this heat from all these processes, uh, radiometric nuclear decay, limestone lithification, tectonic movement, cosmic impacts. If you try to fit it all in just 6,000 years, it becomes a rate of heat displacement so massive it'll completely boil all the oceans and melt the granitic crust of the planet into a superheated plasma hotter than the surface of the sun. And it's impossible to solve that problem because you need millions of super physics heat rejection methods that obviously don't exist. And it's not mathematically possible for them to exist. You need a God who's a deceiver and created a universe with the appearance of age and the appearance of all this radiometric decay that's occurred. And most theologians are going to reject that because if a deceiver God exists, then you can't be sure about the resurrection and salvation. And then this is the final solution, which also really doesn't work, but it's the one they're stuck with. You need miracles or magic to solve it. So God waved his magic wand and shot the heat into space, and problem solved. Hey, what's up, Mike?
Hey, well, I just woke up. So I'm going to get some coffee and I'll be a little bit in and out, but I'm here. But
Yeah.
this heat problem and all these and the time it takes to form rocks problem and all of that. And they just it's amazing. I've talked to them and they hear the problem and they say, "Oh yeah, that's a problem."
Mm-hmm.
But then they go on and they still believe it. I don't get it. I don't understand. So
What I
I
love,
think
Mike, is that the young Earth creationists are the ones who said this is a problem. That was one of the things that the rate team confirmed. It was like
right.
we have this problem. We have this problem because we need the heat to get the tectonic plates moving
Yeah.
at the race car speeds we need for the Pangea to modern landmass distribution model we're using to work. It's a very good problem for them.
I listened to one of them, some video. I forget which. No, it's something like Answers in Genesis. Anyway, uh, and they were talking about how they found possible biological signatures in phosphorus molecules on Enceladus or some moon of Saturn, maybe.
Mm-hmm.
And they said, "Oh, that just proves Walt Brown's right," because Walt Brown said that when the fountains of the deep blew up, 3% of the Earth was blasted into orbit in between Mars and Earth around the sun, and some of it actually went out to hit the moons of Saturn. So I mean, that's why there's life on other. We find these biosignatures, right?
Mm-hmm.
And so I did a little. I did a calculation, a little back of the envelope calculation with ChatGPT. 75 trillion 50 megaton bombs to blast 3% of the Earth away from out into the atmosphere between.
Right.
And it's like, okay, what about what is that arc made out of again? That gopher wood, that's pretty strong shit.
Right.
Anyway, I'm gonna go get a cup of coffee.
Yeah,
Go
no
ahead.
problem.
Okay.
I think we can move on to the next slide. Okay, synapsid evolution. This is one I've been meaning to go more in depth on. It's probably going to be its own video, but we can touch on it a little bit in this one. So the synapsid evolution line, what it basically is it's all about our jaw and our inner ear bones. And here's a couple of images that are relevant to it. This image sums it up pretty nicely, though. As you can see on the bottom, you've got the reptile jaw and ear formation. The reptile ear has a single bone, that green colored bone, the stapes bone. And then the reptile jaw, the bottom part has three bones. It has the dentary, the articular, and another bone. And then the top of the jaw has two additional bones, the squamosal and the quadrate. And then on the top, you have the modern conventional mammal ear and jaw. And as you can see in the ear, it has the stapes. It still has that green bone, but it's gained two more bones. It's gained that blue bone and that yellow bone there. And what we have figured out over time is that the incus and malleus bone of modern mammals are the derived descendants of the quadrate and articular bone ancestors in ancient synapsids. So the bones that were in the jaw of the reptile have migrated into the ear of the modern mammal. And this chart shows this chart shows just the two different stages, the reptile and then the mammal. This chart shows the steps. And you can see you start off with a Dimetrodon at the top. That's a typical reptilian synapsid, pure reptile, pure reptile jaw. So it's got the quadrate, articular, squamous, and dentary all in the jaw, and it's got only the stapes in the ear. And then as we're going down the steps, the articular and squamous, or the articular and the quadrate rather, are moving up towards the ear, and the dentary and squamous are becoming larger and taking up more of the jaw joint. And if you look at the second to last one there, that's Morganucodon. That's the postulated mammal common ancestor, most recent common ancestor of all mammals. And you can see the Morganucodon has a very interesting jaw and ear array. It has both the ancient squamous and quadrate, but it also has the modern formation as well, with the articular and the wait. Oh, it's not the. I meant dentary. Sorry, the articular and the quadrate moving into the ear. So it's a great example because one, the evidence is in all mammals, and two, because when evolution deniers say, "Well, what were they, just deaf while they were evolving this new ear type?" No, they were. Morganucodon literally had stage with both of the formation, so it had no problem hearing while it was adapting to the new the modern mammal formation. So it's a great example of a transformation, and it's example of how at no stage is any of this useless. It all functions. None of it's non-functional, which is what they evolution deniers often claim. They claim that evolution can't work because it won't be functional until the evolved stage. This shows that isn't true. It's functional at every stage. And then these are just to show, if you show an evolution denier these two artistic images that impart a great deal of information, they'll say, "Oh, those are just cartoons." This is to show that no, they're not just cartoons. These are drawings of real jaws and ear bone formations of actual fossils with museum accession numbers that you can go see yourself. So, nope, sorry, conspiracy theory rejected. These are cool. These are called monotremes, and there aren't a lot of them around anymore. There's very few monotremes. It's pretty much just platypus and echidna. And what a monotreme is they're basically a more basal mammal. They're still technically a mammal, but they aren't as derived as most mammals are. And what I mean by that is, like, in most modern mammals now, the secretory system, the mammary glands that feed the young, are a little more advanced and developed. They're it's like an actual nipple. It's an actual part of the body that the young roots around and makes direct oral contact with. It's not that way in platypi, actually. They just kind of secrete their milk out of their skin, and their young has to lap it up off of their skin. It's really interesting. And they have all kinds of traits like that. So they have hair, but I'm not sure if they give live birth. I think they might lay eggs, actually. Mike, do you know if platypi lay eggs or give live birth?
I think they lay eggs, but
Yeah,
I'm
I'm
not.
pretty sure.
Yeah.
Yeah,
That milk secretion thing is really interesting because
it
those
is,
come out of
isn't it?
like something that's almost like a sweat gland. It's a modified sweat gland,
That's exactly it. Yeah.
and then at some point there are different shapes that the sweat gland at some point everted and became sort of something that stuck out like a nipple
Hmm.
instead of stuck in like a cavity, and that takes like one mutation in order for that to happen during
Yep.
development. But then but I mean that is a cartoon version of how it happened. But basically, mammary gland evolution is really interesting because those proteins, like the proteins in milk, you can trace them back, I think, to protozoans.
Hmm.
Some of the core homology of those proteins. So it's really an interesting subject. I have a Google alert set for a man. I forget what his name is now. It starts with an O. Anyway, he published all kinds of papers about the evolution of mammary glands, and it's a wonderful field. But nope, that can't happen. How did that happen? I don't know. Anyway,
So one more point on this before we move on to another slide, if you want to use this against evolution deniers. So platypi are one of the monotremes. There's one other still extant monotreme species, as far as I know, and that's the echidna. And because these two are the only monotreme species on the planet, evolutionary biologists postulated that they shared a recent common ancestor and went looking for it. They estimated where it was and they found it, and it's called the echidnapus. So go look up the echidnapus.
oh
And
really? I didn't know that.
yep.
Let's see. Okay, 5 generally recognized living species of monotremes.
Oh, okay.
Yeah, yeah. 4
What are
echidnas
the
and
other three?
4 echidnas and 1 platypus.
Oh, okay.
Yeah.
Oh, okay. So there's multiple species of echidna. Okay, that's
Yeah.
cool.
Yep.
So that I'm assuming all of those echidna species and the platypus share the common ancestor of the echidnapus.
Yeah. With broad, flexible bill, strong webbed feet, flattened tail,
Yeah.
waterproof fur, dense, no functional adult teeth.
Yeah,
Let's
I
see.
assume that the first humans who took a look at a platypus thought that there was something Mother Nature made after she hit the cannabis a bunch of times. Or
Crocodile.
that,
Yeah,
that some
crocodile.
wacky taxidermist was having half a laugh at him.
Yeah, it was a
Uh,
mammoduct. It was
yeah.
a mammoduct. Yeah.
Oh, platypus doesn't give a toss. It just does what it does.
Yeah. So, did you
Oh,
watch
sorry.
Rebecca's stream yesterday
No.
with where she's teaching that guy named Will or whatever? And
Oh, Will Duffy.
yeah, he's got
No,
all
I don't think I could handle doing that. So the reason why is because Will Duffy has Erica, a PhD primatologist, like on speed dial, who could answer any question he ever has about these subjects 5 million times better than Rebecca can. But he's going to Rebecca because she's telling him what he wants
right.
to hear,
And
and it just
Cornelius Hunter.
infuriates me.
Yeah. It was kind of but he came up with this problem with phonetics and cladistics, basically the difference between figuring out phylogeny from form and the way a thing looks, and then doing it with molecular genetic information. And he said, "Oh, they don't match." And for him, it's really interesting. He's he's well educated. I think he's a decent guy, and his blinkers are very interesting to watch and to understand. And that's one of the things I'm kind of obsessed with. How do these intelligent, nice, normal people come up with something that makes them slam dunk disbelieve evolution? And he came up with a really clear one yesterday, and I thought it was really significant. And it was just that these two different things don't match. Well, Will, the solution is cladistics is far superior. Okay.
Yeah. Well,
It
Erica has
is.
been trying to explain taxonomy and cladistics to him to little
Yeah.
avail. He's resisting acquiring taxonomy skill. And I find that really frustrating because I think
Yeah.
it's one of the things that could shake him out of his evolution denial. And seeing him resist it so much is irritating to me. But
Yeah.
I had a bit of an epiphany about him in that I realized even if he changes his mind about young Earth, even if he changes his mind about evolution, basically still fuck him. He's still a piece of shit. He's still like this
Mm.
anti-choice, transphobic.
Is he
Uh,
really?
oh yeah, super. Yeah,
Okay. I
he,
didn't know that
he's
about him.
he's harassed Planned Parenthood workers so bad that they've had to
Oh,
pick up
no.
and leave town. Like
No.
he's a complete piece of crap. And like
God, I'll never.
I was kind of optimistic at first that he might change his tune about evolution, but the more it goes on, the less optimistic I am about it. I think it's pretty clear that his skill set is
Oh,
uh,
man.
internet religious apologist debate bro and Christian pastor. And that skill set is probably not going to change.
Yeah.
And that's pretty much the only way that his evolution denial would dissipate is if he allowed himself to develop those skills. But he's actively resisting them, it seems to me.
I can only remember being angry enough to hit another man, to beat another man's head in one time in my life. And that was walking into an abortion clinic with my wife. And I wanted to kill that person. And if he does that, that really, and yeah, I don't like people that do that shit. Really made me angry. I don't know. What happened to you, Austin? Oh,
Sorry, Mike. There was a spider. I was letting him out of my room.
you were letting him out. Okay.
Yeah.
You were escorting a spider out. Yeah, that's what I have a bouncer for that.
Yeah, I caught him in a cup and I just kind of let him out.
I hire people for that. Yeah.
But sorry, I missed what you were saying. Something about some static at
Walking
an
into
abortion clinic.
Yeah, walking into an abortion clinic with my wife and being accosted by those assholes. I wanted to kill them.
Oh yeah,
I never felt so compelled to violence in my life because we were so upset to begin with, right?
yeah,
And it was such a tough thing to do. It was such a horrible day. And then we had to put up with these jerks out there just in our face, standing in front of us. And it's just like, oh, I'm going to kill you. And I think they realized that they did give me some space because they could see it in my eyes that something bad was going to happen if they didn't move.
yeah.
Ugh.
So I think
And
the whole anti-choice position itself is really stupid, but that behavior is also especially epically stupid because most of, if not the vast majority of the people that are there, they're there because it's medically necessary. They're having some issue. They have an ectopic pregnancy, or their baby is going to be stillborn anyways, and it's poisoning them from the inside. So these religious assholes are screaming in the faces of people who already lost a child they wanted very much. So,
yeah,
and then the few times where they're doing what they actually want to do, they're screaming at a woman who's making one of the toughest choices of her life. It's so yeah, frustrating for sure.
Yep.
We won't crush whale evolution completely in this stream since we've done whale evolution so many times. But here's the great pictures of whale evolution we've shared with you many times. This is the fact that it's a simplified diagram. Here's all the transitional species, and this is a great one, I think, to maybe screenshot and share around more, because this is a really powerful refutation of the no transitional forms argument. You could use just this slide alone. Sorry, I got a bit of a cough today.
Did, did you put that together, that slide, or is that from somewhere?
I
That
put
is
that
outrageous.
together.
Okay, that's quite a list.
Yep.
Yeah.
So I think this is actually just straight up a catalog of all the species that Gingrich collected, and then there's a Pakistani collection as well, and that makes up the bulk of the whale transitional species. There's like around 220 plus whale transitional species. That's species, not fossils. Species, entire species. There's thousands of fossils, but there's at least a quarter of a thousand whale transitional species. So when evolution deniers say, "Oh, there should be all these transitional forms," motherfucker, there are. There's over a quarter of a thousand in just the artiodactyl to cetacean transition alone. So,
Wait. So I can refute that in 5 minutes. Nuh-uh. No.
yeah, no, another great thing about this is you can take the name of any species on this list, take advantage of modern AI, modern search engines, go to a search engine and search up things like how does blank support the whale transition? How is blank a transitional fossil? And it'll explain exactly to you how it is. For most of them, the answer is going to be something like it demonstrates transitions in the ear. It demonstrates transitions in the pelvis and hind limbs. It demonstrates transitions in the nasal cavity and things like that.
Yeah. I'm
Oh,
just
and the
going to keep
tail.
push. I'm just going to keep pushing back, Austin, because your world. Wouldn't you say that your worldview makes you interpret them as transitional species? I mean,
You're channeling Rebecca today, huh?
I think
No,
I am. I
my
woke up. I woke up on the wrong side of the pillow.
no, my worldview didn't isn't based on presuming these things are transitional. The reason that is because we didn't know any of these existed when Philip Gingrich made his theories about whale ancestor species in the Wadi Al Hatan, the Valley of the Whales in Pakistan. So it would have been possible to presume evolution to interpret these things this way because we didn't know they were there. We had to go out and
Yeah.
find them. So,
Well, there's something interesting about that, and I think you ought to do a meme, and it ought to be one of your creationist principles. They think that worldview applied to evidence can do anything because their worldview, not naturalism, mind you, but
hmm,
their worldview alone can look at uh, phosphorus signatures of life on another moon around Saturn, and their worldview can come up with a story about Noah's flood and God busting open the deep and all this
mhm.
bullshit. And they can interpret evidence any way they want. So they project that onto naturalism and basically methodological naturalism.
They
And they
do.
claim
Yeah.
that we could also interpret evidence any way we want. And if you can't. That isn't how naturalism works.
Right.
Naturalism is highly constrained, whereas their worldview has no constraints at all. They can make up whatever story they want to fill in the cracks in that little Genesis story, right?
Exactly. But they will project and say that we think that nature and time can do anything. And so nature and time are our gods.
Right.
It's really not the way it works. What we're really
No.
just trying to get you to do is to recognize that small changes that are observable in nature within the human lifespan over long time those changes accumulate. You just refuse to do that multiplication problem and come to the product of macroevolution.
Yeah. How many changes and how many transitional forms there were? When you
Yeah.
look at billions of years, like 3 billion years, and you look at the number of species that were covering the earth at that time, and then you look at the number of generations that those prokaryotes could have had. I mean, you have an astronomically large set of small changes, and nobody can get their mind around that. You have to think your way through that. And so that's why millions of years makes a difference, not because millions of years does magic.
Yeah, no, I've explained many times to Donnie, Rebecca, Sal Cordova. I think I said this to him before he said I wasn't worth the time and blocked me and stopped talking to me. They think there's two different kinds of change proposed by evolution. They think there's microevolution and macroevolution.
Yeah.
And what I keep telling them is that microevolution is the process that generated all biodiversity on the planet, both extant and extinct. And they just can't wrap their heads around it. Well, I say that to Donnie, and literally his response is, nuh-uh, like you said.
Yep.
So another great these images, the whale images, are probably my favorite in the whole slide and in the whole slideshow. But I love them because of how interactive they are with each other. Here you've got this piece of evidence that interacts with other pieces of evidence of the nasal migration. It shows a dolphin embryo starting with the nasal grooves on the front of the face. They start migrating up the face. They're about in the middle of the head there, the middle of the forehead you see in the late fetus. And then by the time the dolphin is mature and born, you've got the nasal cavity aperture on top of the head. And this piece of evidence interacts with other skulls that we have. And you can see this same migration occurring. So to me, what that looks like is the embryological development recapitulating the evolutionary development. What do you think, Mike? I know we're not supposed to say embryology recapitulates phylogeny anymore, but it seems like kind of sometimes.
Phylogeny recapitulates ontology, or no,
Yeah.
ontology. Ontology recapitulates phylogeny.
Yeah.
Actually, I think that in a way, there are some parts that kind of look that way, and it's pretty easy to see why that would be something that somebody would say, because there are things that actually do this. They migrate, right?
Mm-hmm.
And
the ear bones are a great example of that, because the pieces of cartilage that become your ear bones start off in your jaw in fetal development.
Well, it starts out at these arches that also are the precursors of gills. So you can, so it kind of looks like the embryo has gills, but it has these little arches. But you can see them in
arches,
humans, all mammals, all vertebrates, and you can see them in fish. And they all start out the same way. And they keep saying, "Oh no, that's been disproved. Human embryos don't have gills." Right? They don't have gills, because gills is what fish have.
Yeah.
Right. What we have is little ear bones and mouth parts and jaws and jaw bones and all of that. But we share with the fish those arches, those little notches that develop in the embryo. So yeah, so I don't really I do not fault the guys with the ontogeny recapitulates phylogeny. Haeckel, Ernst Haeckel. I've been looking into him a bit, and he did a lot more than he is given credit for.
100%.
He did a lot.
So ontology recapitulates phylogeny was wrong in the way that he thought. There are ways that we see ontogeny recapitulating phylogeny, and I think this is a good example of it.
Yeah. Yeah, and there's something called the phylotypic stage in embryology, where if you look between chickens and birds and mammals and fish, you'll find this one stage where the embryo really looks very much like Haeckel was representing it. And it's called the phylotypic stage. And it's an odd thing about development, but development is a lot more complex than that. And you remember, I have 1 year to study that.
Yeah, it's on my calendar. All right, Mike, it's my turn to role play the creationist, and now you have to be the frustrated scientist defending science. I'm going to put on my creationist hat. These are just skulls. This doesn't prove anything. These are just skulls, man. How does this prove anything?
Yeah. How do you know they had ancestors? You know, or offspring. How do you know they had offspring?
Yeah.
You don't know that they had babies. You can't tell. Yeah. Oh, wait a minute. I did it too. We're both creationists.
Yep. Damn it, Mike. Uh, hey, Scott, or hey, Seth. I almost called him Scott. Uh, hey, Seth, good to see you. No problem. Thanks for stopping by and showing some love. And do enjoy the rewatch later. It'll be fun.
Yeah.
All right. So this one we've talked about before. As it turns out, there's two main types of modern whales: mysticetes, which are baleen filter feeders, and odontocetes, which have true teeth in the developed individual. But they both develop teeth in fetal development. So baleen whales who have no use for these teeth, they still develop the teeth buds, and then they develop the baleen plates, and those are what they actually use for eating. The teeth buds are completely vestigial. And it's just more great evidence of the toothed ancestry of all whales. That, along with the involucrum, along with the astragalus, along with all the genetic comparisons, is part of the reason even Answers in Genesis admits they're monobaramin, just like they do with the horses. It's so funny to me because when they admit these things are monobaramins, they're basically just admitting evolution. They're admitting that a small toad forest leaf eating forest dweller evolved into a large hooved plains dwelling grass eating plains dweller, and they're admitting that a small artiodactyl land mammal evolved into the largest animal in existence that's fully aquatic. They're admitting to these huge changes. They're admitting to changes more than big enough that if this isn't a change in kind, you don't need change in kind for evolution.
Yeah.
This is I love these. I think Mike, do you think atavisms and vestigials are some of the best evidence for evolution? Because I would say so.
Yeah, except that you got to be careful with the vestigial term because that sets them off on uh, sends them down a rabbit hole that we don't need to go down. Basically, but yeah, there's I don't like the term best evidence for evolution. It's one of
No.
many things that we can see, right?
Yeah.
Especially in developmental biology, you'll see all of these parts that develop in the same way and end up having different forms. And things like the whale, they never form at all. And so we say, oh, they don't have legs and fingers and things like that. But yeah, they do.
Yeah.
They have a start, but they never get off the ground, right? So
There's such an insanely huge amount of evidence for evolution, and
yeah,
it's not all equal. Some of the evidence is a lot more compelling than other evidence, and I think atavisms and vestigials are a good example of one of those categories of evidence that's a little more compelling than some other evidence. I think genetics is also up there. I think fossils is up there. Uh, but embryology, atavisms, and vestigials are also really good.
if I were to pick a favorite, it would be take a look at the genomes of two different or of a set of extant animals. Take a look at the genomes and
Yeah.
look at the patterns of the genes, and then go ahead and look at our informed and educated guess at the phylogeny, and you will find so much so much in common, and you'll find
Convergence. Yeah.
so much evidence. And when you look at those two genomes, they're just GCTA, right? There's no reason why one sequence of GCTA cannot turn into another. And that's the best evidence for evolution. There is no reason why one genome cannot turn into another going back,
I
right?
agree.
Or have a common ancestor.
I think convergence and consilience is the quote unquote best evidence too. And that's why I
Yeah.
love the whales, orcas, and dolphins line of evidence, because literally the theme of it is cross verification. You've got embryos with the nasal cavity moving. You've got fossils with the nasal cavity moving. You've got embryos that develop atavistic hind limbs. You've got fossils with hind limbs. You've got genetic similarity with hippos that are also artiodactyls. It's just great convergence everywhere. Cross verification out the wazoo. Another picture of those atavistic hind limbs. And here's their vestigial champion, their vestigial prodigal son, the whale penis bone, right?
Mm-hmm.
You didn't know it was going to get sexy on Scientific Origins today. Let's talk about whale penis, baby.
Whale nubs.
Yeah, whale nubs.
15-foot long whale nubs or something like that.
Maybe the whale needs that bone because the whale can't say scoot over, honey. Yeah.
Oh my God. You're good at channeling him.
Yeah. So let's go into this, because this is something you're sure to encounter if you bring up whales. The fact is that these whale bones exist because their ancestors used them for walking. They're no longer used for walking, but that's the reason they're in the whale's anatomy to begin with. It inherited them from a land ancestor that used them for walking. Now, in some whale species, they've been exapted for use in like upholding reproductive organs or helping with other like muscular systems in the whale, like their bladder sphincter or their rectal sphincter, right? But I think
that's the case with all mammals.
Nope.
All mammals have no.
Nope,
so
not the case.
This was an exaptation. Okay.
Yep.
Okay.
So there are actually even species of whales that don't have these bones. Whales and dolphins that either don't have them, or they're so attenuated that they're literally just a sliver of bone, and you can perfectly feasibly fail to find one during an examination. So there's some species where they're so small they can be missed, and there's some species that don't have them at all, which strongly suggests that all the species that have them, they could adapt over time and lose them, and it wouldn't really cause them any issues.
Okay, which bones are you talking about exactly now?
The vestigial pelvis bones in whales and dolphins.
Yeah, but all mammals have pelvis bones, and I think
yeah, they do. Yeah.
And so I mean, and the like extant mammals that have pelvis bones, I'm pretty sure that those same connections, same muscular connections are there.
Okay. I misunderstood you. Yeah. Okay.
Yeah, that's what I'm saying.
I believe that's either the case or that's likely.
I mean,
nevertheless, there are I guess it's actually not true to say that all mammals have those pelvis bones, because there are dolphins, orca species that don't have these anymore.
Oh yeah. I'm guessing that in marine mammals that it would be different, but I'm talking about all the other mammals. They're talking about they do have a function, right? Well, they had a function going back into all the mammals, right? The basically the ancestral mammals had that function, right?
Yeah.
And it spread. So anyway, that's what I'm saying.
Here's what I love. Here's the nuance of it. When you get into the actual nuance of it, when you look at the scientific papers that are related to this, what you find is that the theory that they're useful in reproduction is just a theory. We can't really verify that. Because it's logistically impossible to get x-rays of whales having sex. So it's just a theory. We don't actually know. So that's ironic,
it pisses them off.
Yes,
when you do that.
Right. They won't accept evolution because it's just a theory, but they'll accept that these bones are in the whale because they use them for reproduction, even though it's just a theory. So there's a little fun way you can twist the knife a little bit with them.
Yeah.
So the hind limbs, this image is great for debunking evolution deniers, because one, it's got three main things that you want to notice here. First of all, you've got the ancient limb, and you can see it's complete. It's got the humerus, the radius and ulna, tarsals, metatarsals, and phalanges, right? It's got all those. It's also got the astragalus ankle bone. And then the third thing is here in the modern, you can see how it looks almost exactly like the ancient one if you just cut it in half. And it's got the ball and joint socket still in there, fused in with the rest of the bone. So those three things alone, it's just like, how do you explain that without evolution? And I think the answer is you really can't. So you got to ignore it, and you got to spew some nonsense about, oh, you're just imposing your evolutionary worldview on the evidence and blah, blah, blah.
Right. That's the other thing we're sadly lacking is whale embryology. I don't think anybody's ever really done that.
I've seen some pictures of whale and dolphin embryos, but yeah, I don't know what the extent of the work being done with it is.
Well, I can check into that.
This is my homemade image that I created, comparing phenotype and genotype in the TBX4 gene. And I'm very proud of this image. I think I did a good job on it. I pulled the data from the NCBI genomics browser, and you can see in we've got two land artiodactyl species here that both still have hind limbs. We've got diagrams of their hind limb phenotype, and we've also got high genome convergence in the TBX4 gene. So this explains what the TBX4 gene does, and it shows that it's still active. Over here in the whale, you can see how all the phenotype has severely degraded and eroded, as well as there's major deletions and breakages in the TBX4 gene itself. So this is showing that the descendant of the TBX4 gene for land mammals is still in whales. It's just broken so badly it doesn't produce a full hind limb. It produces some things that have been exacted to some use. And the reason that those breakages weren't selected against is because if these breakages happened in the first two populations, they wouldn't be able to move around. They would starve and die. When those breakages happened in the ancestors of this species, it wasn't a death sentence. They were actually improved by that because they were more aquadynamic. There was less drag on their frame. They were more streamlined.
I have a picture too, I think, that is very much like that. And I was going to show that on the last SNATA. I'm going to try to find it, but I'm pretty sure it was a TBX4 gene I was looking at. But I got to find it for you. Anyway, I'll show it to you.
Yep, the TBX4 generates the hind limbs, and the TBX5 generates the forelimbs. And while there's high divergence in the TBX4, there's high convergence in the TBX5. Maybe I'll make a chart for that too.
Yeah, God got it backwards.
So this slide is specifically good for countering the Preston nonsense. You remember that little chestnut that Donnie and Rebecca both brought up?
Okay. This is what now?
You remember the Preston protein or whatever? I forget what it was called.
Oh yeah.
This is a good refutation of that. This is a comparison of the beta casein 3 differences, and what it shows is that two species of whale, a sperm whale and a right whale, can have as many differences between each other as a whale and a hippo. So they're really, really close to similar. It's basically breaking down why we think hippos are the most similar to cetaceans species, the species outside of the cetacean group that their most recent common ancestor was with.
Right, and the region in the Preston gene that is similar in the bats and the whales, it's similar in amino acid composition, but I would want to look at the genomic composition because that's going to be different
Hmm.
because of redundancy for the code, the 3 codons, and the reason that is the same between those two genes is very, very tiny. I think it's about 12 amino acids, something like that,
Yeah,
and that is statistically highly possible, right? That
absolutely.
two diverging lineages would both come up with that same adaptation for sonar, that
In
sort of
all
thing.
the biodiversity on the planet, yeah, no problem.
Right. And if you look at the rest of the Preston gene, I think you'll find a lot of differences, more similarities between a bat and a human between a bat and whatever's closest to it on the tree than you would find, between whales and bats. So you got to look at the whole gene. You can't. They came up with that little that's one of Rebecca's favorites because
Yeah,
she heard that this one region, this little tiny region in a gene, ended up being similar in these two widely differing branches, right?
yeah,
And she says, "Oh, there you go. That just breaks evolution." No, it doesn't. You have to look at the whole gene, and you have to look at the genetic sequence, not the amino acid sequence, because that's going to tell you a different story. Anyway,
yeah.
and we'll do that. We're going to do that.
One thing that didn't make it into either of these whale and hippo images. Whales and hippos are not only very genetically similar in both the TBX4 and beta casein 3 and telomere to telomere sequences and the endogenous retroviral sequences, captured viral DNA. They're also very similar phenotypically. They're both mostly aquatic. They both have very similar skin and blubber. They both give birth fully immersed in water, and they both nurse their young fully immersed in water. And also, hippos are the only other mammal species that, like whales, have internal testes. So,
Yeah.
a lot of similarities there. And then these are just all the. So when you show evolution deniers the whale chart, they'll say, "Oh, those are just drawings." This is just showing that no, they're not just drawings. They're all based on real species. This is fun. This is not a Rhodoccetus. This is a Pakicetus. When I try to find pictures of Rhodoccetus, it's hard to because they look so much like Pakicetus. Google can't tell the difference. Isn't that fun? And then Dorudon. This one is probably my favorite, if not Basilosaurus. And the reason for that is if you can see floating above its name, the tiny little hind limbs so small they don't even attach to the spine. So they're not useful for anything. You can't even use them for scratching or digging anymore. They're just pure drag on the frame. And so selection is going to select for attenuating and eventually eliminating those things, improving the already very streamlined shape of the organism. The involucrum. So this is a hardened bone inside the ear in an area of the ear called the tympanic bulla. It helps aquatic cetaceans hear more effectively in water. And it's a feature that's only found in cetaceans and cetacean ancestors. So it's really, really strong evidence that all of these things are related to each other, and it's part of the reason Answers in Genesis would admit they are a monobaramin, quote unquote. They're all related. The modern ones evolved from the ancient ones. And then this is mentioning that it's even broader than whales. So whales are a great intro point, but just the existence of marine mammals alone is really strong evidence for evolution. If you just think about the fact that marine mammals exist for a while and ask some questions about it, evolution will start to come into shape for you. And these are some of the other marine mammals. We've got pinnipeds and sirenians. Pinnipeds is walruses and seals. Sirenians are dugongs and manatees. And what you can see in both of these pictures is they're proudly showing off their fingernails.
Yeah, and I encourage anybody to go look at extant whale skeletons because they look a lot different than a whale does because of that big pile of blubber
Mm-hmm.
and some of the expanded rib regions and things like that. But if you look at the whale skeletons, they look surprisingly like those old fossils as
Yeah.
far as their skulls, right?
Yeah, I forget that sometimes that other people haven't seen those things up close, like I
Right.
got to. I personally got to help move around the uh, Philip Gingrich whale fossil collection, and it included some modern whale skeletons, and they're massive. And Mike's exactly right. And I'll tell you another thing: the whale skeleton looks a lot more like the whale ancestor skeleton than the full-on whale does, and
Right.
that's part of the reason we draw the whale ancestors the way we do when we're making artistic estimations of what they might have looked like.
Yeah, I've got one here I can show. Let's see if I can start my camera. First of all, I have to. Uh, know what I did the other day? I did
What's
a
that?
horrible thing. I went and clipped my class pictures from like the 7th and 8th grade. And man, did I look like something I'm not proud of.
Well, I think I had a bowl cut around that time, so I don't know if it could be worse than that. Oh, here
It's
we go. Okay.
horrible. In one of them, I had a bowl cut. Yeah, I had like a Beatles cut, sort of, but except it
Oh,
was
that's a
yeah.
great one. So you can see the complete lack of hind
This is
limbs,
beluga. Yeah, beluga
very
whale. But
streamlined body. You can see the nasal cavity is on top of the head.
yeah, and
Uh,
look at the skull, and look at the humor, the shoulder blades, and all that. I
yep.
mean, there's, yeah, I'd have to fact check
If you
this, but
move
I
your
think
cursor
it's
down a little bit,
you get away from my mouse, you little monster.
you can see
That's
the
cat.
humerus, the radius ulna, the carpals and metacarpals, proximal,
Yeah,
intermediate, and distal phalanges, the full pentadactyl limb. Great picture. Love it.
but look at the skull. The skull doesn't look like what you would suspect a whale skull to look like,
No.
because they're all because they have that big blubber
Yeah,
thing
there's a
going on,
big
right?
circle around
Right.
this thing. Yeah.
Yeah, and blubber is interesting because it's nothing more than fat
Right.
that expresses the collagen inside of the fat. So blubber is kind of an interesting structural fat. It's like a real stiff fat,
Hmm.
basically, and it was a
Basically,
very
yeah.
small mutation in order to turn fat into blubber, which is a very different thing than just fat.
Yeah.
And that's one of Rebecca's big things. Oh, how did blubber form? It's like it ain't that hard for blubber to form. It's basically a
Blubber
little bit of
is
collagen.
blubber is starting to form in the mammal populations that are currently occupying the niche the whale ancestor would have, and that's populations like otters and polar bears, which is the
Really?
final
Okay.
point I wanted to make on this before we moved on.
Ah,
That otters and polar bears are currently filling those niches, and they are developing similar adaptations. Wouldn't you know it?
okay.
I think we're getting close to the end of this year. This is something I've been working on for a while. I put together the taxonomic address of humans. This is maybe not every single one of the clades we belong to, but
Oh,
it's
nice.
really close. I've got
I
71 of the clades we exist within put together here. And what this is demonstrating is the way taxonomy works.
yeah.
There's a single most broad taxon in existence, and that is the biotic taxon. That's everything that's alive. And then if you take that category and you make it more and more specific by 71 criteria, eventually you get to the genus Homo and the species of Sapiens down at the bottom. And
Oh,
then
that's nice.
I
I was gonna do that. I'm so
go
glad you did that for me.
yeah, go ahead and print screen this, put it together, and then this is just the raw data, and then here's what the information imparts. This list is literally what we are. It's telling us what we are. We are
Yeah.
archaean eukaryotic. We're derived archaeans that have gone through a bunch of endosymbiosis. We are amorphians that conglomerated to become thelazoans, multicellular animals. And then those multicellular animals developed a body plan as fish in the water. They developed lungs, bones, lobe fins, and then there was a land transition. Then there was the reptile to mammal transition, and then we are the specific group in the mammals, the primates, and all that. And so, if we didn't evolve from apes and monkeys, why are we still apes and monkeys? If we didn't evolve from Sarcopterygians and Osteichthyans, why are we still Sarcopterygians? If we didn't evolve from all these things, why are we still these things? So it's great.
I want to point out Rebecca yesterday with Will Duffy. He had a real problem understanding why we would call ourselves fish or tetrapods or whatever,
Yeah.
because he was confusing it with kinds and with characteristics, that sort of thing. And he was confusing ancestry and phylogeny with how we would morphologically look at something, and he realized that he did not that he was conflating cladistics with phonetics, and so his mind was almost right there, but he was still in denial. So it's really interesting, and that's why I mean, even though the guy might be a piece of work in other fields, it's really interesting to look at how these Christians are thinking and look at the stumbling points that they come up with. And that's one of them that we could do a whole deep dive on, about how they would confuse this kind thing and this, with Jim Bob's essences and all that. And that is something we really need to concentrate on. Now, I want to understand the creationist mind. I want to be able to think like they do. And at some point, I would almost like to believe like they do. And I've been working really hard to switch my mind around so that I can see what they're stumbling on. Right?
Well, we should be open-minded, but not so open-minded that our brain falls out. And I don't want to be unkind, but I think evolution deniers are kind of indoctrinated and brainwashed.
They are, and but I want to find out how that works. I want to find out how that works. I want to be able to. I don't know. Maybe if I took some mushrooms, and like got into their shoes for a moment, I'll have this revelation where I'll realize where they're going astray. And one of the things where they're going astray, Austin, is that they don't understand the molecules. No. None of them have a really good molecular biology background. They may have a biochemistry background. That isn't necessarily a good molecular biology background. Right. So they go astray there because they can't imagine how these molecules could do all this stuff, right? But that's what I do every day, is imagine molecules. So anyway.
I like looking at them.
We're trying to help them, Austin. We're trying to
kind of. I want to help them where they can be helped, but mainly I want to keep them from doing more damage.
Yeah, sometimes I just want to wring their necks, right? Most of the day, that's how I feel about them. But every now and then I find a soft spot and I try to help them.
So this is just getting into more depth about what I was talking about previously about. You can basically divide these into a couple of different stages, and that's an easier way to digest what all the data is showing us. So like these are the stages of cellular foundations. This is where our cytology developed, and then multicellularity developed. This is the body plan. So once the cells are together, they start doing things like making things like an excretory system, like a protokidney or a kidney, or they start making respiratory systems like a lung, or they start making things like heads and necks and limbs. And then this is the stage where those heads and necks and limbs started crawling out of the ocean and diversifying and adapting to life on land. And then this is the part of that stage where some of those land things became mammals. This is the part of that stage where some of those mammals became primates. And then this is the part of the stage where the primates became humans. Yeah. These aren't complete lists of all the changes that occurred, but this is a good synopsis. You can screen cap every one of these if you want to go over part of the transition with an evolution denier. And if they ask you for molecules to man evolution, you can give it to them in 6 screenshots.
Is this a PowerPoint presentation you have?
It's a presentation I made, and then I uploaded it to StreamYard. I uploaded
But
the
is it
slides.
is it power? Oh, slides.
Yep.
But is it PowerPoint?
Yep.
Okay, can you send that to me, please? Because
Absolutely.
you got some really great stuff here.
Yeah, for sure. This is why I
These
wanted
are
to.
these are better than I have seen anywhere else.
This is why I wanted to do the stream. I said before you came in that a big part of me figuring out that young Earth creationism was untrue was seeing images like these on the internet. So sharing them for ammunition for sure. So I'll definitely send it to you. Here we've got the blended transition of humans. This is a great one. I love using this image. Evolution deniers, they're very vocal about evolution a lot, even though they don't seem to really understand it greatly. And they'll say things like, there's no evidence of evolution. And then you post something like this, and they're like, those are just skulls. I'm like, yeah,
Yeah,
skulls are evidence.
yeah. Those could have been like deformations of humans after
Right,
the
yeah.
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 Yeah,
Trust me, these are
like
just humans with really bad posture, bro.
like the Neanderthals. Somehow they went off and went up into the glaciers, and they inbred, and they got severely deformed to create an entirely different kind of skull than we have. So
Mhm.
we know how that works.
Another good thing is to ask them to just draw a line where human is and ape is, and 99% of them aren't going to be able to do that.
No.
This image is great. I love this image because it makes things so much less confusing and nebulous. So when you talk about genomic comparisons, there's a lot of different ways genomic comparisons can be done. You can compare the entire genome. You can just compare the aligning regions. You can compare only the introns. You can compare only the exons. You can compare all kinds of different things. This image shows like three or four different comparisons in just one image. So what
Yeah.
you're seeing is the pink is the introns,
Symphony.
the untranslated region. These are genes that don't produce proteins, so they're just biochemical noise, basically. And then the purple parts are the exons. These are genes that actually produce proteins. So these are the things that are like actually your body plan, like your actual
Yeah.
phenotype is held just by these purple lines. And
Few and far between. Yeah.
and what you can see is that in these first three species, both the introns and the exons are super similar. They're
Yeah.
all really similar. And this is what we mean when we say, a human and a chimp are 98% similar or 86% similar. You can see how much of this bar, the human to human, is present in the human to chimp. There's very tiny chunks of it missing. And
Oh, that's a
there's
wonderful
still
picture.
very tiny chunks between a human and orangutan, but larger than the chunks missing between human and chimp. Sorry,
Yeah.
go ahead, Mike.
And when I go and look at these areas, when I look at the actual sequences between the chimp and the human, I have a hell of a time finding differences.
Yeah. Yeah, it's hard.
Unless, of course, you look at, some genes have been shuffled around. And of course, we have the chromosome 2 fusion and all that. I mean, other than that, when you look at a specific sequence anywhere, introns and exons, you have a hell of a time finding a difference.
Yeah.
And one key difference, and I found a couple and then I lost them, but in those intron areas, every now and then you'll find a transposon that's in the chimp but not the human.
Mm-hmm.
And that is really important.
Yeah.
Because when you go ahead and look at other things like the orangutan, you're not going to find it there either.
Mm-hmm.
And those are the things that would falsify evolution. If we found a whole bunch of those that were in the same place and in two separated species, but we didn't find them, in close species, that sort of thing.
Exactly. Yeah.
That's really interesting work.
And then another great part of this slide is the last two species. With the mouse, you can see there's some intron and exon similarity. There's some intron similarity, but then all the exons are still very similar. And then in the zebrafish,
Yeah, the
there's like
purple part.
no
Yeah.
intron similarity, but all the exons are still very similar. So what this is showing is the conserved regions of
Conservation.
genomes
Right.
are very common amongst animal species. Even with a zebrafish, we share a large amount of the actual protein coding genes that we have.
Right. And if you want to look at relatedness, you really want to look at the non-conserved regions because
Yeah.
that's where you see it most stunningly.
Yeah.
Because that's where a mutation can freely happen and doesn't matter. That's
Exactly.
Yeah.
Yeah,
Those are the
for
pink
sure.
areas.
A good one to screenshot.
Yeah. Yeah, that is wonderful. Where did you get that out of a paper?
I think it has a source on the full image, but it isn't poking out in there. I've been asked about the source before. I hunted it down. I'll find it again and get it for you, Mike.
Yeah, okay. Thank you. You know me and sources.
Yeah, for sure. I love these pictures. These are less. They're data driven still because you can see behavioral, morphological, maxillofacial symmetry, but they're really emotional too. When I look at these pictures, I feel the kinship we have with primate
Yeah.
species. The
Yeah.
the mom holding up the baby on her legs and playing with her. Who hasn't done that with their mom?
Yep.
And then this other picture, the smiles, the mirrored expressions of happiness, the love. It's just beautiful. And some people are like me, stubborn, and they have to do all this training and studying to figure out evolution denial is wrong. Other people are probably more clever and they can figure it out just by looking at one of these pictures.
Yeah. Yep. My mom would have never done that. My dad did that. My mom sat in the corner wringing her hands. You're gonna hurt my baby.
So then here's some more pictures just showing the overwhelming phenotypic similarity. So we talked about the genotypic similarity, but the phenotypic similarity is overwhelming too. Bones, muscles, joints, tendons, skin, organs, skulls, brains, babies, hair, spines, fingers, and fingernails. All these things are in the same place, doing the same thing in all these species you got pictured here. Here's you got a chimpanzee with alopecia. You can see her skull. You can see her leg muscles. The way her body looks so similar to ours is just mind blowing to me. And then the baby behavior with the grasping reflex is the same too. And then in the other picture, you've got the skeleton of a modern human and a gorilla. And you can see they have the exact same bones in every spot, doing the exact same thing. It's just mind blowing to me. And this one's just a funny little jab at them. Raise your hand if you share a common ancestor. Oh, I guess that settles it. Stay mad about it, evolution deniers. Again, just this is
Oh my God.
this is an illustration of a phenomena that's very visible. It's very apparent, and that is that primate babies look so similar to each other. A human baby and a gorilla baby look almost exactly the same. A human baby and a chimp baby look almost exactly the same. A human baby and an orangutan baby. The infant stage is so much easier to see the similarity and comparisons in primate species. It's wild. And
Right,
this
and that
image,
goes back to that ontogeny recapitulates phylogeny thing that you see when you look at embryos,
mhm,
The earlier you go back, and that also has a whole lot to do with why there was a Cambrian explosion, but we
mhm,
could explain that in another video. It's very interesting to think about those early animal forms and how and hierarchies and how it was so much easier to modify at the early stage than it is at the later stage, which is where we're at now. So
yeah.
anyway. I just
I
want to
love
point
how
that.
not only how similar they look, but like how they have the same facial expression going on right now.
Yeah, I
They're
know.
both
The same.
like,
Yeah.
I think it's a rooting expression, or
Yeah.
maybe it's just
Same.
they're pursing their lips or something. But
It's like,
same.
it's a ooh, ooh,
Oh, ooh, yeah.
ooh.
Ooh,
Yeah.
I'm born. I'm a
Yeah.
living
Ooh, I
baby
like that.
now.
Yeah.
This is another great one. I love this
Oh my
one.
God.
Dolphin fin versus a human hand. Dolphin species typically have 26 to 27 four-limb bones. Humans also have 26 to 27 four-limb bones. Exact same number, exact same formation. The similarity is just overwhelming, right? It's mind-blowing to look at.
Yep.
And then this is a simple illustration of how the common descent works. Creationists sometimes, evolution deniers sometimes think that a human evolved from a chimpanzee, evolved from a gorilla, evolved, when really this is how it works. They all draw back to a common ancestor. The one on the right didn't evolve from the one on the left. The whole row evolved from the node that they all draw back to. Hopefully
Yeah, and
that's clear.
looking at those common ancestors instead of extant chimpanzees and gorillas and things like that,
Yeah.
would there we would look that common ancestor would be kind of a cross between both of us. And like chimpanzees with the the mouth, the way the mouth is formed and all of that,
Mm-hmm.
that happened later, probably
Yeah.
after the split, right? And that's why these it's very misleading to look at extant images, right? You have to
Right.
always go back and think about that common ancestor and try to figure out what that might have looked like, because that would tell you more than these pictures, is what I'm
Yep.
saying.
And
Am I, am I
Dan,
getting in your way, Austin?
no, you're great. Uh, this is Daniel Leroy's favorite. He loves this one. Uh, and I got to tell him that not only are there fish that can walk, there's fish that can climb trees.
Oh yeah, yeah, that's cool.
Isn't that mind blowing?
Yes, that is. I
I
hate
think
when they do that.
think we're getting close to the end here. I like this one. I've
I
used this
know.
as a thumbnail once or twice.
No, that should be
There's
Rebecca.
no
That
evidence
should,
for evolution. Yeah, exactly.
yeah. But instead of her hands over her eyes, she's got this dismissing smile. She's got this constant smile that is always like, "Oh, my cute little evolutionists. They're trying to tell me a story, but I'm not listening to
I,
them."
I, I'm seeing her like holding up papers as like a barrier, so she doesn't have to. She's
Yeah,
just like covering it up. She's like blocking it as you're moving around. She's like, yeah, block, block, block.
yeah,
No, I don't see that. I don't see that. I don't see that.
yeah, right, yeah, yeah,
And I think this
yeah.
is a good one. There's a little summation of the debate, the way it seems to work. No matter how much evidence you present, the creationist is just going to say, not good enough, and tell you to keep trying. Maybe one day they'll become something other than completely impervious to evidence, but it's not unlikely. Or sorry, not likely. So that's the end of that presentation. Obviously, it's not all the images that helped me figure out evolution were real, but it's some of the big ones, and hopefully you get some use out of those. Mike, did you have an image you want to share there?
I did, yeah. I've been meaning to show this. This is the UBX gene ultrabithorax. And what it does in insects is it keeps limbs from forming on the abdomen, right? They'll form
Mm,
on the thorax, but not the abdomen.
yeah.
And the interesting thing when you look at this gene, this is the C terminal region. You see up here where all the A's are,
Mhm.
all the alanines, basically. This is actually a protein sequence, not a gene sequence. But that those repeating alanines, right? They were a copied sequence of genes that created a new function, and that new function look like that, which means that the new function was to repress the DLL gene, right?
Hmm.
So that is a new function, even though the creationists would say, oh, it lost its limbs, it lost genetic information. This shows you that no, this is a gain in genetic information right here that causes it to shut off another gene. So here we have a gain in information that basically represses something that looks like it lost something, but it didn't lose something. It gained information. You understand that?
Yeah.
This this particular little motif here is a new genetic bit of information that created a new function to shut off the DLL gene. Now, if you look at older or basically ancestral or ancestral arthropods, which would be crustaceans, they have limbs forming all the way down, right? So they don't have the UBX function that shuts it off. So insects are, oh, I hate to say it, but more evolved in that they added a function, basically. So here is where a mutation added functionality to the developmental process. And that's really like, I'd like to see a creationist get his mind around that and really understand what I'm saying here. Because
Yeah,
this is
I'm
new
gonna do a
information.
video debunking the evolution denier talking point that you can't add new information pretty soon. Yeah, I'm working on it, Native.
Well, this is a really good thing to really understand what's going on here. Because when you switch something off, sometimes you have to add genetic information in order to make that switch it off. And that's what happened here, the UBX and DLL. Distalis is DLL and ultrabithorax is UBX. But that's one of the things that I'm learning about when I'm studying that embryogenesis stuff I'm supposed to be working on. So there you go.
If you really want to show monetary support, Native, you can. I've got my like Cash App and Venmo up there, but I don't really ask for it. I'm getting closer to the number of subs you need to get super chats going. I think it's 1,000. I'm up to around 350 now. I'm working on it slowly but surely.
Dave did it at, didn't Dave do it at 500? Or
It
no,
might be. I don't know.
maybe that's anyway, guys, I'm only like 60 away. Would you please help me out if anybody
Yeah,
hasn't
absolutely.
subscribed? Please. I'm getting older. Anyway.
Yeah,
I'm getting
so
old and senile.
there's some great images. I'm going to make a video addressing the no new information trope probably this week. Oh yeah, another thing about insects, since we're talking about those, there's a biomolecule that only exists in insects and fungi called chitin. And I think that is another really interesting piece of evolutionary evidence. But I'll talk about that on another video.
I could talk about chitin. Yes.
Yeah. Oh, whoops. Sorry. Wasn't trying to remove you from stage there. I was trying to
yeah, I want to talk about chitin at some point.
So, yeah, that'd be cool.
Yeah. Okay. Yeah, you gotta. There's another button you got to hit to make us normal again. So
yeah, I'm trying.
I'm taking over. I know they seem to. It seems like StreamYard changed something. I don't know, but I'm not sure. Anyway, we're good. Cool. Please send me that PowerPoint.
Yeah, absolutely. And I'll be uploading a bunch of those images onto my YouTube post section. So for sure, go check that out. Guys, if you're a subscriber on my channel, definitely check out my playlists and posts. I'm not just putting out live streams and videos. I've been putting a lot of work into those too. So for sure, check those out. Like, comment, subscribe, do all the free ways of supporting me for sure. Everybody in the rewatch, thank you for watching. Everybody in the live audience, thank you for watching and live chatting. Native Atheist, you a real one. Thanks everybody, and thank you, Mike, for coming out. And I hope you enjoyed talking and looking at the pretty pictures.
I just woke up from a nap, so most of my brain is tied behind my back. But I try anyway.
Yeah. Well, you know what? Looking at pretty pictures is a low of mental effort activity. So
Yeah,
it's a good
but
one for it.
these were some of the prettiest pictures I've seen in months. So wonderful, Austin. You're doing great work.
I appreciate that, Mike.
Yep.
And I think with that, we can sign off. Thank you, everybody, for stopping by. Much
Yep. See you
appreciation.
guys. Bye, cruel world.
Goodbye, cruel world.